Welcome back, all my aspiring mathematicians. Today I'm going to dive into the unit of rational expressions. And the topic today in that unit is how to add and subtract rational expression with uncommon denominators. I'm going to take you back down memory lane when you were taught how to add and subtract fractions. As you should recall, a rational number can be written as a fraction, which is a ratio of two numbers. So you will have a number in the top, which is called the numerator, and then you will have a number in the bottom, which is called the denominator. I'm going to show you an example of how we are going to tie the concept of adding rational numbers into adding rational expressions that have uncommon denominators. So if you were given a over c and you were told to add it to d over e, you will notice that the denominators here are not the same, meaning that they are uncommon. And so for this example, you will have to have these two multiply together. You can write it as this, or you can write it as simply CE. It doesn't matter. So I like to tell my students to write as this, okay? And so when you are adding these, what you'll have to do, because this is first one rational expression here, this is another rational expression, so you have to take the denominator. How many times can it go into what you have here underneath? And so you will have c into ce is going to be e, and then you will multiply it by a, and you will do the same thing for the other side. You will have e into ce, which is going to be c, and c is going to be multiplied by d, and you put that there. And you will end up with AE plus CD over CE. And that would be your final answer. Now, this is for simply a rational expression when you are using simply variables there. Any letter of the alphabet, we can use that as an example. Now, I'm going to show you how to do that with fractions. And this is going to spark your memory a bit. So now I'm going to choose to use 1/3 plus 2/5. If you notice here that the denominators are uncommon, meaning that they're not the same number, so we can't just put one number when we draw our line. We are going to end up with multiplying the 3 by 5. Some people might want to do this, which is fine, but I rather say just do 15 and put the 15 here. But if you are not versed in math, you might want to start out with this first so that you can easily see where I'm going with each of these steps. So we will now say 3 into 3 times 5, which is going to be 5 times. That's going to be left, so you put the 5 here, and then you're going to multiply it by the number in the numerator, which is going to be 1. So you can basically see here, it's fine if you had put 15 underneath here, that is okay, and just say 3 into 15 is going to be 5, and 5 times numerator is going to be 1. So now you can say 5 into 15 is 3 times, or 5 into 3 times 5, you're going to be left with the 3. You can put the 3 here, and then you multiply that by 2, and you will end up with 5 plus 6 over 15. And you can add these, and that is going to give you 11 over 15, and that would be your final answer. So that's it for adding and subtracting rational numbers. And now I'm going to show you an example where you're going to have variables along with numbers, and that is going to be your rational expressions. So let's get into our first example here. So our first example is going to be x plus 5 over 3. And we're going to do minus 2x plus 1 over 2x. Now, some of you might say to me, oh, miss, can I just cancel out the 2x with the 2x? No, you can't do that, because one is a binomial and one is a monomial. You cannot cancel these out. They're not the same term. So you will notice that this is a monomial term, this is a binomial, and so you have another number here added to this expression or this term, so you cannot simply just cancel that out, and that's the reason why I'm using this example. So I am adding on to prior knowledge that you should have into this example. So let's go ahead and we are going to add and subtract these. To start off, you must draw your line there, and we are going to multiply 3 by 2x. I like to do it like this instead of just writing the 6x, but if you feel comfortable just writing the 6x, that is fine, just like I did with the 15 over there. So now you're going to say 3 into 3 times 2x. You're going to be left with 2x. So you put that 2x here, right? And so when you put the 2x there, and then you're going to multiply it with what is on top, which is the numerator, x plus 5. You bring down your subtraction sign. 2x into 3 times 2x is going to be simply 3, and you're going to multiply that with the numerator, and you would end up with this. So now you come down, right, and you're going to multiply this out. So you will have 2x times x is going to be 2x to the second power. 2x times 5 is going to be 10x. And negative 3 times 2x is going to be negative 6x. Negative 3 times 1 is going to be negative 3. You place that under 6x. You find you can change it now. It's up to you. Now we have to combine like terms. So we're going to combine our like terms, and you will notice off the top that these two terms here are going to be the same. So you're going to combine them. So you will end up with 2x squared, and 10x minus 6x is going to be positive 4x minus 3 over 6x. And there's nothing you can do with this. It cannot be factored out anymore. Okay? So you have to leave this as your answer. As you should know, I like to give various examples to show you that there are various ways that the question can be posed to you, and you have to know how to tackle those questions. So let's get into the second example. So our next example is 4x over x plus 5 over x plus 6. These are two sets of rational expressions, and we're going to add these. All right. First one we did was to subtract. Now we're going to add these. So we draw our long line here, and then we are going to do the math for this. You will notice that the denominators are not the same, meaning that they are uncommon. So we have to write them like this. Okay, so that's one of the reasons why in the first example I did not want to go ahead and just multiply the 3 times the 5 and just write the 15, because I want to get you to note that you have to write your expressions like this from your denominator when you're multiplying them. So now you can say x into this that you have here, the x and the x plus 6. Once you do that, you will end up with x plus 6. So you can have x plus 6 here. And you're going to multiply it by the numerator, which is 4x. And you're going to bring down your plus sign. Now you're going to say x plus 6 into this product here, and it's going to be x. So you have the x there, and the x is going to be multiplied by x plus 5 that you have on top. We now have to use our distributive property, and once we use our distributive property, we will note that 4x times x is going to be 4x to the second power, and 6 times 4x is going to be 24x. And bring down our plus sign there. X times x is x to the second power. X times 5 is going to be 5x over x parentheses x plus 6. Okay? And we have to combine our like terms here. We have two sets of like terms here. We have this set, and we have this set. And then the other set that we have is the 24 and the 5x. So let's put it together. So we have 4x squared plus x squared is going to be 5x to the second power, and we are going to add that to 29x, because 24x plus 5x is 29x over x parentheses x plus 6. You can take out your GCF. So x can go into this, so you can have x parentheses 5x plus 29, and this over x parentheses x plus 6. Now from this you can now cancel out your x there, and your final answer is going to be 5x plus 29 over x plus 6. And that is going to be your final answer. I hope that you do realize the transition in terms of the examples that I'm presenting to you. First, I started out with simply in the denominator as our uncommon denominators. We have the number 3, which is a monomial constant, and then we had a monomial. And then for the second example, I had a monomial, and for the other denominator, I had a binomial. So you will see the transition there. Now my third example that I'm going to demonstrate to you, check this out. You're going to see what's coming next. So our third example is going to be x over x minus 3, and we're going to subtract 2 over 3x plus 4. You'll notice that in this example, the denominators are both binomials, but they are still uncommon denominators. So let's get right into solving this problem. So I will draw my line here, and I will have my x minus 3 parentheses and the 3x plus 4 parentheses. X minus 3 into this product here, you're going to be left with 3x plus 4, and I'm going to multiply that by my numerator, which is on top. Bring down your minus sign. 3x plus 4 into all of this is going to be x minus 3, and then you multiply by the 2 that you have on top. All right. Now we are going to apply the distributive property to this in order to arrive at the correct answer. So 3x times x is going to be 3x to the second power. 4 times x is going to be plus 4x. Bring down your subtraction sign. 2 times the x is going to be negative 2x right there. So I want to point out to you that because you have it written like this, if I had wrote the 2 first and the x minus 3, I want to show you that you would end up with, because you have the negative here, you would end up with negative 2x plus 6 here. The same thing here, because even though you have a 2 on the other side, it's going to be a plus 6 at the bottom. So you have to be careful there, and that is because of this negative right in front of here, because you would end up with the negative 6 here, right? So it's negative 2x, negative 6, but the negative here, which would be this, you have to turn it into a plus sign. Then you're going to place that over x minus 3 parentheses 3x plus 4, and now you have to combine your like terms, and you will notice that these are your like terms that we have. So it's 3x squared plus 2x plus 6 over x minus 3 parentheses 3x plus 4 close parentheses, and that is your final answer. You can also go ahead and use the distributive property and multiply this out, and then you can write that over, so you can have this to be written as 3x squared plus 2x plus 6 over 3x to the second power, and then that is going to be plus 4x, and this would be minus 9x, so will be minus 5x and minus 12. So you can write it as this, that's your choice, or keep your answer as was in the cloud. So in conclusion, I hope that this lesson has helped you tremendously, and that now you know how to add and subtract rational expressions with uncommon denominators. You have to look out for that. Once the denominators are uncommon, you have to treat it like this, and you cannot just use one number at the bottom because the denominators here are different. If the denominators were not different, then you could have gone ahead and treat it differently. If you don't remember how to do so, you can go back and watch my video on how to add and subtract rational expressions, but those expressions do not have uncommon denominators. The denominators will be the same. So please adhere to all the steps that I laid out, where you have to treat your uncommon denominators and write it as a product here together in parentheses, and then you are going to follow the same steps. Now that you know the steps that you have to follow, when you are given a rational expression to add it, most times the books are not going to tell you, or the problem is not going to say, oh, they have uncommon denominators. You have to look at the problem and realize that the denominators are uncommon. If they are not the same, then you have to follow this concept. If they're the same, go back and watch that video on that I have that can help you in doing so. That being said, I hope that you will not keep this knowledge to yourself. You will pass it on to someone else so they too can learn how to add and subtract rational expressions with uncommon denominators. And if you have not yet subscribed to my channel, what are you waiting for? Go ahead and hit that subscribe button. And guess what? Hit the like button too if you like what you see. And leave me a comment. I like to read your comments. And thank you for watching, and see you soon on the next video to come. Bye now.